In these video notes, we are going to look at how to solve one-step equations that have multiplication and division. For the first equation, we have the problem x divided by 5 equals -2. So I'm just going to rewrite it. That gives me a little bit more room to solve it. We are always going to use inverse operations to solve equations. So if I want to undo dividing by 5 or get rid of the dividing by 5, I'm going to multiply by 5 on both sides. Okay, so if I take a number x and I multiply it by 5 and then divide it by 5, I'm just going to be left with 1x, since 5 divided by 5 is just 1. And then on the other side of the equation, I have -2 times 5, which is equal to -10. Then for the check it step, I'm going to start with my original equation, x divided by 5 equals -2. And in place of x, I'm going to substitute what I think x is equal to. And then just check. -10 divided by 5 is -2. And that's what it was supposed to equal. So I know that -10 is the correct answer. Okay, second one, I have the equation -72 equals 8 times d, or 8d. If I want to undo multiplication, the step that's going to undo multiplying by 8 is dividing by 8. Now, when you divide by 8, I don't want you to use that division symbol. That's not what we're going to use when we're solving equations. Instead, we're going to use the fraction bar and show that we're dividing both sides by 8. So -72 divided by 8 is -9. And 8d divided by 8, 8 divided by 8 is just 1, so I get 1d. I could also write that as -9 equals d, since 1d and d are the exact same thing. Okay, in the check it step, I'm going to copy -72 equals 8 times my value for d, which is -9. And then I can test it and make sure that both sides are equal to the same thing. 8 times -9 is -72, and that's what it was supposed to be. So I know that -9 is the correct answer. And then I'm also just going to label check step for both of these. Okay. When you are solving equations, it is very, very important that you are showing the step that you're doing on both sides. So showing times 5, divide by 8, divide by 8. That's what we'll be looking for when you turn in assignments. All right, next one is very similar to number 2. We have the equation 3 equals -1.5 times n. And to undo multiplying by -1.5, I'm going to divide by -1.5 on both sides. So on the right-hand side, where the variable is, -1.5 divided by -1.5 is just 1. So I get 1n. And now I need to figure out 3 divided by -1.5. If I'm not sure about that right away, top number goes inside the division box, and the bottom number goes on the outside. So 3 divided by 1.5 would look like that. I know it'll be negative, so I'll deal with that later. Okay, we always want to make sure that the number we're dividing by is a whole number. So I'm going to multiply by 10, and that's going to slide my decimal over one spot. 3 times 10 would be 30. So 3 divided by 1.5 is the same math problem as 30 divided by 15, or at least they have the same answer. 15 goes into 30 twice with none left over. So I get the answer of -2 is equal to 1n. Okay, if I'm checking that answer, I'll reset here. Start with my equation. 3 equals -1.5 times n. And n, I believe, is -2, so times -2. And then I can just test it. 1.5 times 2 would be 3.0. Negative times a negative is a positive. And since I get 3 on both sides, I know that negative 2 is the correct answer. All right, next we're going to look at a couple that have some fractions in them. And just like before, I can divide both sides by the coefficient. Here's the thing though, there's actually a shortcut. So for these steps right here, I just want you to watch, don't write them down yet. I'll reset and let you know when you need to write them down. So normally to undo multiplying by 2/3, I would divide by 2/3. And that still holds true here. The thing is though, it gets a little bit messy when I have 14 or negative 14 divided by 2/3. Remember from fraction operations, that would be the same as negative 14 divided by 2/3. And when you divide by a fraction, you're really multiplying by the reciprocal. So I end up flipping my second fraction. So what I can actually do to make the steps look a little bit more easy to work with, instead of showing dividing by 2/3 on both sides, and actually I need to change that to 3/2 now, I'm going to do that step in the beginning. So I'm going to multiply both sides by the reciprocal, which would be 3/2. On the right-hand side, I would get 6/6x, which is the same as 1x, or just x. That's what we wanted. And then on the left-hand side, I can put this as negative 14/1, if that helps. So 3 times 14 would be 42. 2 times 1 is 2, and a positive times a negative is negative. Negative 42 divided by 2 is negative 21. So I get 1x is equal to negative 21. All right, those steps were a little bit confusing because we were trying to show why that worked. So for this next one, we're just going to jump into using the shortcut. So I'm going to start off with negative 8/5 b equals 5. And to undo multiplying by negative 8/5, I'm going to divide by negative 8/5, and that's the same as multiplying by negative 5/8 times negative 5/8, both sides. Okay, on the left-hand side, that would be positive 40/40, which is just 1. So I'll get, those will cancel to be 1b. And then on the other side, I can line it up to make 5, the fraction 5/1. That would be negative 25/8. And then I can just write it as a mixed number. 8 goes into 25 3 times with 1/8 left over, and that's going to stay negative. Okay, I'm skipping the check it step here just to make the video a little bit shorter, but you could plug that back in. Make sure you got the same thing on both sides. Okay, next one, we're going to write the verbal sentence as an equation, and then we're also going to solve. So I'm just going to go step by step. A number would be my variable. I'm going to choose to use n. Then it says divided by, and we're going to use a fraction bar to show divided by. The number negative 9 will be my equal sign. And negative 16 is just negative 16. So I get the equation n divided by negative 9 equals negative 16, which matches the verbal statement. Okay, then we're also going to solve that equation. So to undo multiplying by negative 9, to undo dividing by negative 9, we are going to multiply by negative 9 on both sides. So that's going to cancel and give us 1n. And now we just need to figure out 16 times 9. So that would be 54. 9 plus 5 is 14. Negative times negative is positive. So n is equal to 144. Okay, last one. We have a school election where 3/4 of the students vote. There are 1,464 ballots. We want to find the total number of students in the school. So first, it might be a good idea to just check and see if we're looking for a number bigger than 1464 or smaller. Since only 3/4 of the students voted, we're going to need a bigger number because those 1464 ballots doesn't represent everyone, but only a portion of the school. Okay, so let's start by defining a variable. It tells us that we need an equation to find the number of students. So I'm going to use S to represent the number of students in the school. Okay, now let's kind of break it down piece by piece. It says 3/4 of, so I'm going to do 3/4 of is typically going to be multiplication. I'll actually use a dot so it doesn't get confused with the variable. And then it says the students. The number of students, we're going to use S. So we're going to do 3/4 times S, and that amount is equal to 1,464. So equals 1,464. Now it looks kind of similar to the last couple equations we solved. We're going to multiply both sides by the reciprocal. So I'm going to do times 4/3 times 4/3. So this side simplifies down to just 1s. And on this side, it might help to make this over 1. I could also simplify the 1464 first if I wanted. So here's what those steps would look like. I'm going to do 1464 times 4, since I'm just multiplying straight across. So this would give me 5,856 for the numerator over 3, or divided by 3. So now I'll do 5,856 divided by 3. Okay, and when I divide that, I get a total of 1,952. So that would represent the total number of students in the school. So S equals 1,952. And since I had a word problem and my variable represented number of students, I'm going to put units of students on my answer. All right, we were expecting to get a number that was bigger than 1,464, and we did, so it seems like our answer is reasonable. All right, once again, when you're showing your steps to solve these equations, be sure you're including that step on both sides. That is what is going to get you full credit. All right, thank you for watching. Good luck.